Hello friends, welcome to part 2 of my lathe restoration series. Now in part 1 I said that I would take care of the rust on the ways next. But as of now I haven't decided on which method to use for the ways, and that's why we will do that later. We will first use some chemical rust removal methods on other parts of the lathe in order to test those methods, and that will be done in an experimental video, most probably in the next lab report. In this video I will work on the tailstock as well as on some paint jobs here for the frame. And for now I simply apply some ballast toll to the ways in order to prevent further corrosion on the ways. In order to visualize where the parts that we are going to talk about will eventually be positioned, I have now put the headstock on the left and the tailstock on the right end of the ways. Now in Germany we call the tailstock Reitstock, which means ride stock, which kind of makes sense since it can ride along the ways. And once you have positioned the tailstock where you want to have it, you can then clamp it down by means, in this case, of a single large clamping bolt that you will see later in this video. By turning the hand wheel, the tailstock spindle can be pro and retracted. Once it's in the right position, it can be clamped down by means of the tailstock spindle locking lever. When the spindle is retracted far enough, the cone-shaped dead center can be removed from inside the spindle. Now you might have seen that there are two holes in the walls of the spindle. And that is of course a modification that a former owner has made. And I guess he probably did this to connect this smaller of the two 3-jaw chucks that came with this lot to the tailstock. And I will later try to connect a drill chuck to this tailstock. And I really don't like this rather sloppy modification, to be honest. So I will now take apart the tailstock as far as possible, and this will help us with getting really familiar with all the parts of this lathe. And of course we also have to clean and de-rust and re-oil all of those parts individually. And we start by removing this large bolt and all the other parts that belong to the mechanism that clamps the tailstock base onto the ways. And you can see here that the bolt, the smaller parts, and this threaded handle here are rather rusty, and they are some of the parts that will be treated by means of a chemical rust remover later in this episode. And I first again retract the spindle so far that we can take out dead center, to then protract it so far that we can take out the spindle from inside the tailstock. And my disassembling process ends with unscrewing the locking bolt. Of course there still is the hand wheel and some parts inside the tailstock, but I want to leave that as it is. But in order for you to see what is inside the tailstock and also to name the parts in German, let me go over to a graphic that I have provided here. The dead center, in German called Zentrierspitze, which means centering tip, is sitting inside the opening of the tailstock spindle, in Germany called Pinole. Now the mating surfaces of these two parts are shaped according to a mathematical formula that gives them a conical shape. In English this is referred to as bored taper, in German meaning konisch verjüngt. The tailstock spindle locking lever, in German called Klemmhebel, is in this case simply a bolt that is sometimes referred to as a Knebelschraube in German. With some lathes you will also find a bronze nut sitting at the end of the tailstock spindle, but with my lathe this is not the case. The large screw that you can find inside the tailstock is often referred to as the shoulder screw. In German we call this part the Spindel or spindle, because spindle is just the common word used for a threaded bolt in the German language. That might also be the reason why we call the other part that you call spindle the Pinole. And of course there are all sorts of alternative names in use in different countries, in different periods of history, and by people with different educational backgrounds. And just so that you can check it, I have put some sources in this picture because that's where these terms are coming from. Now here we have some drawings of different tailstocks from around 1915, and you can see that of these 6 tailstocks here, the one in the upper left corner is the one closest to the one on my lathe, and that is because it is the only one that does not have a slide and a slide adjusting screw. Such a slide would allow for adjustment in transversal direction. Expressed in simple terms, that means that you can move the tailstock further away from you or closer to you if you stand in front of the lathe. So now that we have talked about all the basic components that are used in this rather simple tailstock of this lathe, we can go on with some practical work, and that is to remove the old paint from the tailstock. But before I start with sandblasting, I cover all openings with the help of some paper and different kinds of tape, because that would be the proverbial sand in the gears, prohibiting the shoulder screw and the spindle from moving. And after the old paint has been removed, I again use brake cleaner to clean off the dirt and grime from the bottom side of the tailstock. And yes, I know I'm using rather aggressive methods here to clean off the ways and also the base of the tailstock, employing things like brake cleaner and gasoline and so on. And you normally use kerosene when regularly maintaining a lathe, but in this case it's really just about proper degreasing, and maybe it's a bit too aggressive. But just know that I apply ballastol directly after the surfaces have been dried. And I use the oil for the entire bottom side of the tailstock. And you can see here that of course there is wear on the bottom side, but I will not grind off any of the surface material here for now. And I use some manual wire wheeling after the sandblasting to get off the remaining paint that was covered by duct tape so far. And we will repaint the entire tailstock together with the legs and the machine bed later in this episode, but first let us try to get the rust off all the miscellaneous parts that belong to the tailstock. Now in the comment section of the last video, many people have made suggestions about different products for rust removal. And I have bought this stuff here called Rostio, which seems to be the closest thing that we have in Germany to navy jelly. And I guess it's based on phosphoric acid, just as that stuff you have over there. And I will show you the results of my work with this in this video. But I will give you all the details and compare this stuff to other more do-it-yourself methods of chemical rust removal in the next lab report, and I'll post that in the comment section as soon as it's online. I first degreased and cleaned the surfaces of the hand wheel with some universal thinner and waited for the material to dry. I then applied a several millimeter thick layer of Rostio to the surfaces. Then waited overnight because I didn't have any good results after 1 or 2 hours, and again removed the rather dried jelly from the surface of the hand wheel. And I did that with some water. And after I did that, I also polished the remaining surface with some steel wool and re-oiled the material. And I repeated this process with all of the other parts of the tailstock, and let me just show you the results with a little before and after comparison here. As I said, I will give you some more of the details of this process and compare it to other chemical and electrochemical processes of rust removal in the next lab report. So at this point I really had a lot of parts with raw iron surfaces, and I had to decide whether to paint them now or later. And in part 1 I said that I would probably wait till the end with that, but frankly I never thought that this restoration project would be such a long-term thing. And because of that I will now simply paint the parts from part 1 together with the tailstock. And I thought about using a paint gun for this first, but I then decided to use an old-fashioned brush for this, because there are a lot of irregular surfaces and also a lot of spots that I would have to cover. And for example, taping off the oiled surfaces of the ways and on the tailstock really wouldn't be so fun. So I said, let's just use a paintbrush. I mean, it's a lathe, not a sports car or anything. So the type of paint that I'm using here is a polyurethane-based structure paint that was specifically designed to be used in industrial applications, for example for the enclosures of electronic devices or for vehicles, machines and so on. The color is RAL 7021 dark gray. Now some people might not specifically like this on a machine tool, but the rest of my workshop is basically covered in this paint, my drill press, my workbenches and so on, and I simply happen to like that color. But if you don't like it, well, it's just a matter of taste, so you're free to pick any color you want. So with the cast iron parts repainted, the paint dried, and with all the parts derusted and oiled, we can put the tailstock back together. So and with the whole bed, the legs and the tailstock painted, it starts to look a little more like an actual lathe. And in the next video we can start to work on the headstock. And as I said, there will then also be another video in which we will experiment with chemical and electrochemical rust removal methods. That video will be a lab report and thus a little more experimental and trial and error in nature. It will not be official part of this restoration series, but the results of those experiments will then definitely be used within the restoration project. So I will start working on the headstock, I guess tomorrow, and I will see that I go through with all the stuff that has to be done here in the shortest time possible and let you know about my progress here.